Hello students. In last lecture, we have seen that examples on second principle of mathematical induction. Okay, working rule for that second principle of induction is we have to prove this result for n is equal to 1, which is our step 1. We have to assume that the result is true for n is equal to k, where k is less than m. And the last step is we have to prove that the result is true for n is equal to m. Then only the result is true for all natural number n. Here in this lecture, we consider one more example on second principle of mathematical induction. Here, let an be a recursive relation defined by, here an is defined as an is equal to 2an minus 1 plus an minus 2. It is a recurrence relation n greater than equal to 2 with initial conditions that a0 is equal to 1 and a1 is equal to 2, and we have to prove that the relation an is less than or equal to 5 upon 2 raised to n. This is our statement. An is less than or equal to 5 upon 2 raised to n. Okay, so go for the solution. Here let p of n is equal to an, which is less than or equal to 5 upon 2 raised to n. 5 upon 2 raised to n. Okay, we will prove this result for n is equal to 2, since here starting value of n is equal to 2. So first we prove this result for n is equal to 2, which is our step 1. So for n is equal to 2, our LHS is an. LHS is an. The relation of an is given as an is equal to what? 2an minus 1 plus an minus 2. An is equal to 2an minus 1 plus an minus 2. Here substitute value of n is 2. So by substituting value of n is 2, here we get 2a, 2 minus 1 is 1. That is 2a1 plus a0. Okay, an is equal to 2a1. Our an n ची value 2 म्हणजे a2 is equal to 2a1 plus a0. So if our initial conditions, we have given that value of a1 is 2 and value of a0 is 1. So 2 into 2 plus 1, that means 5. So our LHS is 5. Okay, now our RHS is 5 upon 2 raised to n. Value of n is 2. That means 5 upon 2 square. 5 square is 25, 2 square is 4. 25 by 4. 25 by 4. So this value is less than 4. So 5 is less than 25 upon 4. 25 upon 4. That means this value is approximately 6 point something. Okay, this value is 6 point and our LHS value is 5. That means our LHS is less than RHS. LHS is less than RHS. That means our statement is true for n is equal to 2. Okay, so we clear here first step. Now we assume this statement is true for n is equal to k, where k is less than m. We assume this statement is true for n is equal to k, where k is less than m. So in particular for m minus 1, m minus 2 which are less than m. m पर्यंत m पेक्षा लहान असणाऱ्या सगळ्या टर्मसाठी our statement is valid. So m minus 1 is less than m and m minus 2 is also less than m. So this statement is hold for the m minus 1 and m minus 2 also. So if the statement is hold for m minus 1, then we get a m minus 1 is less than or equal to 5 upon 2 raised to m minus 1. We replace n with m minus 1. If the statement is hold for m minus 2, since m minus 2 is less than m, we get a m minus 2 is less than or equal to 5 upon 2 raised to m minus 2. Okay, this is our second step. Now we have to show that our statement is true for n is equal to m. Now we have to prove that our statement is true for n is equal to m. So our am is 2am minus 1 plus 2a plus am minus 2. Our statement is am. Okay, now value of an is 2an minus 1, 2an minus 1 plus an minus 2. We have to find am. So here replace n by m. 2am minus 1 plus am minus 2. Okay, so by a previous step, here we substitute the value of am minus 1. Value of am minus 1 is 5 upon 2 raised to m minus 1. The term am minus 1 which is less than or equal to that term. 2 into 5 upon 2 raised to m minus 1 plus am minus 2, which is less than or equal to 5 by 2 raised to m minus 2. Okay, this statement is hold for the terms which are less than m. Okay, so here the first term is as it is, 2 into 5 upon 2 raised to m minus 1 plus 5 upon 2 raised to m minus 2. This can be replaced by 5 upon 2 raised to m minus 1 into 5 upon 2 raised to minus 1. We splitted the term that m minus 2. m minus 2, it can be written as m minus 1 minus 1. स्प्लिट केले आपण त्याला. 5 upon 2 raised to m minus 1 into 5 upon 2 raised to minus 1. Okay. Now here 2 into 5 upon 2 raised to m minus 1. This term is as it is. Then this term is 5 upon 2 raised to m minus 1 as it is. And this is 5 upon 2 raised to minus 1. So this term is can be written as 2 upon 5 raised to 1. हा त्याचा इन्व्हर्स आहे. 5 upon 2 raised to minus 1 म्हणजेच काय 1 upon 5 upon 2. So 1 divided by 5 upon 2 which is equal to 2 upon 5. That means 5 upon 2 raised to minus 1 is equal to 2 upon 5. Okay. Now look at these two terms. In these two terms, 5 upon 2 raised to m minus 1. This term is common in both. Okay. So taking 5 upon 2 raised to m minus 1 is common. 5 upon 2 raised to m minus 1 is common. So here remains 2 and in the second step remains 2 upon 5. So that means we get here 5 upon 2 raised to m minus 1 into 2 in bracket 2 plus 2 upon 5. By solving this bracket we get 5 into 2 is 10, 10 plus 2 is 12, that is 12 by 5. So 5 upon 2 raised to m minus 1 into 12 by 5. But the term 12 by 5 which is less than 5 by 2, since 12 by 5 is 2.4 and 5 by 2 is 2.5 and 2.4 is less than 2.5. So 12 by 5 can be replaced by 5 by 2. आणि 12 by 5 च्या ऐवजी आपण 5 by 2 लिहू शकतो कारण 12 by 5 ही टर्म 5 by 2 पेक्षा लेस आहे. ओके. सो हिअर वी रिप्लेस 12 by 5 विथ 5 by 2 कारण इथे आपल्याला 5 by 2 हवे होते म्हणून आपण ते रिप्लेस केलं. ओके. सो नाऊ वी गेट 5 by 2 raised to m minus 1 into 5 by 2. Here 5 by 2 has power 1. So power is same. Sorry, base is same. So by rules of index here taking addition of two powers m minus 1 plus 1, that means 5 upon 2 raised to m. That means we get here am is less than or equal to 5 upon 2 raised to m. That means our statement is true for n is equal to m. Therefore by second principle of mathematical induction our statement is all n is true for all n greater than or equal to 2. So here we consider first step, we prove this statement for n is equal to 2. If the statement is true for n is equal to 2, then our second step is we assume that our statement is true for all k where k is less than m. If it is hold for m, there m minus 1 and m minus 2, this is very important step, m minus 1 and m minus 2 are less than m. Therefore m minus 1 is less than or equal to 5 by 2 raised to m minus 1 and same am minus 2 is less than or equal to 5 upon 2 raised to m minus 2, since our statement is hold for m minus 1 m minus 2. Then our last step is we prove that our statement is true for n is equal to m. Okay.